All right, just give a couple minutes for everyone to join in.
Hey Luis.
Hey, Srinivas, how are you?
Hey, I'm good. I'm good. Today looks like very few number of people.
Yeah, let's give a couple more, we'll give 2 more minutes and then we'll start the discussion. In the meantime, if anyone has any questions, just feel free to put them in the chat.
Hello.
Hello.
Can you hear me?
Yes.
Please, this is Ravi. So I just have one question for you or the management. In the last session, I was kind of like, on the road when the session happened. I couldn't participate, the board, and then you are writing some notes, people are participating. So can I still study that or not?
Yeah, for sure. I can give out the link to the Miro board and that way you can have a copy. Maybe what you can do is we can put it in the WhatsApp for those who, like you said, who's gonna be able to attend it and do them, so they can have a copy of that. So let me just pull that up. Just give me a minute.
That is all I have. Thank you.
Yep, no worries. I'm just getting this right now. Password here. Okay, found it. All right, so Manoj, I'll give you then the link again, and then and here is the password that they would need to access this. So we can put that in the WhatsApp group for those who missed it and want to
Sure.
and want to study from that.
I'll share the info.
Perfect, thank you. All right. I think I owe you guys one more thing too as well. I think I guys owe you the slides, half the slides that we did in week 3. I didn't share them immediately because there's still half the lessons that we didn't go through, but I know some people like to read ahead, so that's fine. So what I'll do is I'll put that into the Gen AI training thing here. Upload that document now. Okay, so I pass that over. All right. What everyone thought about on Saturday's class. I know it was more an activity to get the brain going in terms of understanding how actually would use this strategy, right? This week is also like this the week was also after that. What are some principles? What are some main ways of how you can lead the change in your organizations? And what are some simple ways of doing it as well, right? So those were the major points. We didn't finish half of it because I think one main point was to get everyone more engaged, thinking about these problems and statements. And again, I think it was really great comments from everyone across the board of how they would have how they tackle these strategies. And so we know we have about 13 people on board. Does anyone have any questions? It doesn't have to be a question about the week's class. If you have a question anything about Gen AI or anything around there, you're welcome to ask questions as well. And if you even have ideas, this can be an office hour for that as well.
Yeah, if anybody doesn't have a question, I have general questions on the AI related. So, how many neural networks are involved in developing the AI model? So, is
That's a
it
really
like, yeah,
That's a really good question. So it's interesting that the talk of neural networks and everything comes up because it's one of the things that we talk about in General 101 of how it's an evolution, how in the beginning, before LLMs started, what we used to do was doing neural networks to really try to capture nuances, trying to capture everything that was happening. But then there was a revolution in 2018 when Google released something called the BERT model. The BERT model was sort of the first model that could start looking at words and classifying them based off different types of rules and different types of text and different types of like it was like its own. So we call this more a transformer type of model that used it as a transformer and completely changed the game. And then after the BERT model came out, then we got into GPTs, and GPTs are the training models from there. So I can give you a quick snapshot, if I can pull it up, of what we go through on 101. Um, let's see if I can pull
can
it up.
can I have just a small additional question? Can the BERT model be used to develop another uh, your own AI model for your native language, or do I need to have like my own neural networks and stuff?
Yeah, so the BERT model is more for classification. So if you had tons of text and you wanted to classify certain sentences, certain paragraphs to be certain things, then a BERT model would be the best part for that. But if you want to train a model to really be and to really be about a certain language, then you need to use a GPT model which have two types of transformers in it. An encoding model, which is how you train it, and a decode is how it sort of comes out. So let me just pull this up quickly. Pull that up right now. Let's see if I can find it. Week 1. I don't have it on the spot because I didn't think I'd be talking about this tonight. So just give me 1 minute. Go look at our WhatsApp groups. Maybe I'll just pull this up this way. GPT encoding, decoding. Okay, maybe it's easier for me just to pull up on Google. So let me just share my screen. So there's a lot of things happening in terms of architecture. So I'll go back and talk quickly about what's really goes in there. So I'll pull up a BERT model first. Maybe that seems to be a more BERT model. And good, simple architecture. Okay. So when you think of LLMs and how they work, you need something to sort of encode it. So encoding is the process of looking at tokens, looking at the embeddings. There's different types of, like you were saying, neural networks that need to be done, right? So you can train a BERT model to look at certain languages and then classify them. So let's say you have a paragraph of 100 words, or like 100 paragraphs of English, Spanish, French, Hindi, whatever it is, and you can train a BERT model to recognize what are the type of languages, because a BERT model is to really, its job is to encode things, so it's more of an encoder. Then we have a GPT. This is where you heard the word GPT comes from, right? ChatGPT. GPT comes from the form of being able to generate pre-trained tokens. So it's able to generate actual text. A BERT model can't generate text. It can only classify. So how do you train a GPT model? It's sort of, if you see here, is a combination of both. So you have a data set of the language you want the model to learn, and maybe you have it in English as a classification, as this is the words, this is what the translation means, etc. You feed that to your BERT model. This is where the training, when you were training a model, comes from. And you train the model and you give it and you pass it to the GPT. Now the GPT has all this information. You can then use that information to output text. So you sort of need that. So here's maybe a better picture that sort of separates the two. So the BERT model is what was created first, then went to GPT model. But in order to create the GPT model, you need to have a BERT model that trains it to train the BERT model into the GPT model. So this is what we call LLM training. So this is what people do when they try to create their own LLMs. They create this BERT model to train everything and how it works that way. I know there's a lot
Okay.
of information, but
Okay. Yeah. So one additional question, right? This is mostly like text, correct? But if
yeah.
it is audio, what would be so does that still apply, or how will it change if I add the audio dynamic?
Yeah, so you need something called a multimodal model architecture.
So is there a multimodal BERT architecture, BERT or
Yes.
GPT?
It's sort of like a GPT architecture in that sense, but it has a different and has extra layers than you would see in a normal BERT model. I'm trying to find one. Hopefully, they will have a good example. Because you don't need, so what happens is when you have a multimodal model, it's not only looking at text like you were saying before, but you need to have like a vision model if it's looking at images. If it's doing audio, it needs an audio decoder. It needs to have different types of neural networks built in that can handle different types of text coming out. So an example, yeah, I think this one is this is an example of a vision model that has a spatial conventional block. So you need to have, like, the multimodal model will have many different ones versus like a typical language model that we saw here. So you need to have the neural networks inside a multimodal model will have vision, audio, and image. So there's definitely a lot more layers to it than a typical one. But that's a very good question. I don't think anyone from 101 has asked that question before, so kudos to you. Trying to get to that deeper section. But yes, I'm just trying to find a good example of that, but there's definitely a lot more neural networks that need to be done for that to have audio or even images. This is why when you go to look at the voice, even the voice API, um, in the voice API in ChatGPT, you'll see that for text it's like 0.01 cents, but for voice you'll see it charging like $5 for like 100 tokens. So it's a lot more. It's a lot more expensive to use.
Uh, so when you develop the model, do you give the phonics, I mean the sounds of each alphabet or vowel uh, sounds each, uh, or how does it work? How do you train? Do you train by words and the associated sounds for that, or how do you train?
I think so. If you're talking about if you wanted to train something yourself and you wanted to learn how to train a multimodal model, I would first start using an open source multimodal model that already has voice and sort of already has brains behind it. So how I explain on 101 is that for a model, an LM to be smart, it needs to have at least to be trained on data. So for example, Meta just trained it on text, but they said if they didn't train it on Python, it wouldn't do mathematics properly. Or if it didn't train it on physics, it couldn't understand this. So you need to have a model that already has a brain, I would say, of pre-existing conditions and roles and how that works. Once you already
Okay.
have a model that can think, it can act and stuff like that, and it's a multimodal model that can already do like voice to text or anything like that already, you can easily train another language on top of that model because then you're just giving it an extra layer and making it so it's using the smartness that it already has and you use it on that. So how would that work is um, you would have a voice to text transcriber decoder. So just like images or anything else, when you have 1, 0, 1, so it'll convert everything into tokens. So every synthesizing voice, everything you have to have recording, you have to have a recording of a certain voice pattern. Once certain voice pattern happens, it gets recorded as a token encoder. Those token encoders are the ones how it trains the model. So you hear the word ah, the ah when you break into a decoder will decode that word ah sound into 100 100, and then comma then would be the next sound. Eh. So what you're trying to do is train the model saying if you see 100 150 000 that's a one sentence, right? So when it replays and decodes that audio, you have something that's able to it's able to recreate that sound based off that token. Now the hard part in the stuff is if you're trying to train it in LLM without any smartness, it won't know what context or where to put the A beside the C or what letters you need to have. This is why having already a smart base model that understands how nouns, grammar, everything like that happens is to be done. So you sort of need to have a voice decoder training data set in order to do this. So this goes a little bit deeper, but very high level. Yeah. So audio gets decoded into gets high decoded into I would say tokens or serial numbers, and that's what gets fed into the model to get trained, not the actual voice.
Okay. So which is the base model for that? Is there any base model?
Yep. There's
Do you
tons. There's open source multimodal models.
Okay, I'll find out if there are.
There's like a bunch of them. Let's see one. Let's see. I don't like this. Let's go to Hugging Face. Hugging Face is where I do my typical repository search. In Hugging Face, there's an example. Yeah, 5.4 is a multi. 5.4 is from Microsoft, and it's one of their top smart models that came out. Um, and there's tons of them out there. So this one has audio, vision, text already built in.
Okay.
Yeah, so this would be a good place to start. And then you can simply just download it off the files and versions.
Hmm.
This one is actually small, so it's actually like 12 gigs of model itself. but it's actually a pretty smart model. But yeah, that's definitely a good start to go from.
Okay.
All right, awesome questions. It's a good start for this office hour.
Luis, one question from my side. So we are using all the models that are there in the public cloud, which is actually like going to get charged. So if I want to have like any tools for summarization, meeting summarization, let's assume, okay. So I try to use Nutshell, which is actually doesn't take any data to like the cloud. But when I asked to summarize, it was actually like taking a lot of time. 20 minutes it took when I explored that. So is there any tools actually like that actually like offline, including our Mac, works efficiently, right? So if I have a good GPU, obviously like some of the models might work pretty nice, but like the existing Macs or traditional CPUs that we have without pretty expensive GPUs, what models are recommended?
So I would say there's something called Ollama. I'm not sure if you guys heard about this one before. Ollama is meant to optimize any of the Llama LLMs and be able to run them locally without spending or burning your GPUs. So Ollama, what it does is, let's say it's you use the small version of Meta, so 3.1, for example. And there's different types of sizes, 8B, 70B, and 405B. So let's say like I would say a good starting base would be that 70B model. But if you were to run 70B, that means you need to have 40 gigs of RAM. You need to be able to run it exactly from there. And that will take a lot of your memory, right? So I would first start with the 8B model, which is only 5 gigs. So if you have a 16 gig RAM, this can definitely take on this. Ollama will do is peel off layers of the 8B model to make it more efficient. And this is what you do to sort of run things locally without spending API credits or anything like that. So if you're able to download 3.1 from Hugging Face, the 8B model, run it with Ollama. Ollama is sort of like a wrapper that you can put on around the model, which can handle it. What it does is it runs the model in C++. So Ollama runs it in C++. Grabs the model, converts it to C++, and runs it that way to make it run faster. And it's able to run, and you're able to do this. So this is something I was going to do with in 103. But this is how you would sort of run a model locally and not worry about going to the cloud. And you can do is you can run Ollama in a private server. You can have it in sort of in your own black box area, right? That you know that doesn't have any access to internet if you really want to be more careful. But you'd be able to run your own model offline. So definitely try 3.1 Llama 8B with Ollama. There's tons of tutorials how to run Ollama out there, but definitely try with a smaller model. If you're saying the summary is like really bad, then try 70B. But then you can do something called quantization. So I'll put that in the chat. And quantization is when you quantize the model to be something smaller. And this is when I talk about peeling the layers off the model. So let's say there's over 100 layers in the model. When you quantize it to, let's say 16, you can remove the top 30%. And therefore it's not 40 gigs anymore. It's only 25 gigs. And you don't really see a degrading performance from there. So I definitely would try Ollama. Ollama is really fast. If you don't use Ollama and just try to run 3.1 8B on your local thing, it will still take you about 4 or 5 minutes to get a response. But I found using Ollama and running with that, I was able to get a response within seconds. So it really optimizes the model to be the best to be used that way. So that's something I definitely would recommend if you want to try how to use an LLM locally on your computer. And so it is. And like you see here, there's tons of tutorials and YouTubes to help you run that locally. But I also run that through 103 as well. But this should be a good start.
Yep. Thanks, Luis.
Well, Luis, a follow-up question on Ollama.
Yeah.
Is the Ollama faster because it does quantization or because of other things?
So yeah, so like I said before, what Ollama does is it actually it runs everything in C++. So when you run it on your VS Code Simple, like whatever you're running it with, so you could be there's different ways to load a model locally. So you can use a Hugging Face Python function that pulls everything in. You can use these other functions to run local llamas, run your LLMs. But what I found that Ollama I was trying to read into what it does is actually uses C++ to then look at the model code. What it did it's actually it's called Ollama because it actually looks at the LLM how it's sort of being put into different sections and it's able to run it faster, read it faster, and be able to run it that way. So it's been way more optimized. And you can even see here that even LangChain uses Ollama because it's more popular and a lot of people use it to find it to increase speed. So it's mostly about it being more optimized for the meta models. But you
Yeah, I
can
mean, I heard about people using Ollama on their laptops, but I was just wondering why it's kind of faster. Never looked into that. But just because of C++, it can't be so fast. Probably it does quantization and other things.
it doesn't quantize it. I checked. You would have to in order for it to be quantized, like it has to remove things from the model. Let's see. Go here. Let's go
I mean,
along.
just C++ does it so fast.
It's not, I don't think it's not just that C++ does it so fast. It's Ollama has dissected the model and knows exactly where to pull from the model. So let's say how I would describe this is an LLM is like an onion, right? And inside the onion, there's multiple layers, and each layer is wealth of knowledge, and but it's everything has to be connected somehow. So Ollama has sort of been trained on how the architecture of Llama is built and knows exactly when to hit the transformers, knows when to pass it through. So it's built for it's pretty much built to speed up the processing between the transformers. But it's not exactly because it's C++ makes it faster. It's just Ollama has been trained on the architecture of Llama and knows exactly how to pull information faster that way. That's my
And so,
understanding.
what is the downside? Because everyone can be faster, right? I mean, everyone can be like Ollama. So, there should be some downside, right?
Let's see here. I think it was, yeah, so like I said before, Llama architecture composes multiple layers where each layer learns the patterns and speech, and then Llama pretty much optimizes the transfer between the data. Um, Yeah, so I haven't seen a lot of. You can choose. What I've seen people do is they created a front end for Ollama, and you're able to then to quantize the model in the UI frame itself. But when you run Ollama at the beginning, you're not quantizing it, but you can in that front end quantize it. Um, Yeah, so these are the top ones. Like I said, Phi 3, Llama 3. So it's sort of been optimized for certain models to run faster on. That's what I know. So I don't know I haven't seen anyone talk bad about Ollama in terms of the bad, like in terms of the degradation of messaging. But that's a good question. I can look into it later. I haven't seen anything. I haven't heard anyone say anything bad about Ollama yet. Let's see, downsize. Hmm. Yeah. Yeah. So there's no like yeah, I'm trying to look online if anything bad with performance. Everyone just says it's how it's good, how you can use it to quantize pretty faster, and it's really efficient. So it's something I'll definitely look into it if there's a downplay on it. But this
Yeah.
is sort of the go-to of if you want to run everything with running it. So for sure. Good questions.
And a question on that, diagram where you are showing the transformer, GPT, and BERT, where you're showing all three of them.
Yes,
Uh,
I think it was this one. Yep, so this is the BERT model and this is the GPT model.
you had another diagram where they are next to each other, three of them.
Yeah, there's some of the, so yeah, it's pretty much what it does is it separates like this picture and then this one separate and then this one separate.
So,
But,
I mean, given that you said GPT is decoder only, right?
yes,
So in Chat GPT, is it a transformer or a GPT model?
that's a great question. So if you look at this, you would only use encoding and decoding only in terms of training a model. So when you first train a GPT model, you would need a BERT model to classify and train your documents, and then pass it on to a GPT model, which will then grab the information. So once you're done this training, you can disconnect the BERT model from this, and this is what LLMs do, and it just becomes the output, which is your GPT model only. So you can't. So for example, for this is like you can't go into ChatGPT and give it tons of data and say, I want you to train on this data set. It will say what? Like it doesn't like, I'm sorry, I can't do that for you. I can try to memorize information for you, but I can't train myself to do that, right? In order for it to learn more information, you would have to do something called fine tuning, which is then again you use another BERT model to fine tune, like going back to the onion example, fine tune certain layers of the onion to have more layers for the model to learn. And that's how that model works. Then you would disconnect the fine tuning when you're done and leave the GPT only. So the GPT is like a frozen LLM in which you can only give information when you tune it or when you train it or you fine tune the model. But you need a BERT model to sort of tune the GPT models.
Okay.
So hopefully that makes. If you want me, I can repeat it a little bit
Yeah,
slower.
yeah. I mean, that makes sense. Yeah, that makes sense. And kind of like a related question on that Olama thing you just mentioned, where it is like only 9 GB or something, right? Um, so whenever you say this model is this much size, what exactly is stored in that?
That's a good question. So there's different sizes of models that are out there. And what you're trying to do is, I guess, like the law of physics, you want to have the smallest model with the highest memory efficiency. And this is something maybe you've seen in the news about DeepSeek, right? Um, DeepSeek, the new DeepSeek has come out. It has, it's matching what ChatGPT is doing, and you're just like, whoa, how could it do it? How can it be so good and how can it be so efficient? So what it did was the difference between ChatGPT and what DeepSeek did was ChatGPT scraped everything from the internet, used that as training material in their BERT model, then trained their GPT on that and that got information. And that was sort of GPT 3.5. But then as people went in, use it to ask questions, gave thumbs up, come thumbs down. That's called reinforcement training, and they reinforced which responses were good. And then they found that okay, all these people are saying this is awesome, other people this is bad. Let's use that information and train our model again. So when they did that, they trained it to ChatGPT 4.0, ChatGPT 4, and that's what it is. And they're slowly optimizing now different architectures and trying to get to be faster, right, with their O1 Pro, etc. Blah 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 blah. So when we say what are the different sizes and everything like that, it's the size of the training data set. So once you have something that has says 670B, that means 670B 700 billion parameters was used to train this model, which could mean trillions and trillions and trillions of tokens. So
When you say 65 billion parameters, each parameter is one token?
no, there could be multiple tokens per each parameter. So when I say 670 billion parameters, it could be 3 to 4 trillion tokens. And how I would say it is one word could be 2 to 3 tokens for it. So one word, it's really based on which LLM you use, is like different rules. But when you say 600, like when you say parameters, it's regarding not just one token, it's multiple tokens at that time.
How is it mapped? Like when we say Llama 65 billion, right? How is it mapped to all the training data or tokens versus this parameters? Well, I'm just trying to understand where they get the size parameters.
Yeah, so example, let me pull one up here. So Llama 3.370B. So let's go for 3.70B billion let's see billion parameters. I'm trying to see if they have the architecture broken down here. If not, then I'll go to the files. Instructions, tuned models. That's just the things here. Let's go files and versions. Okay, so in order for you to use a model, you have to know sort of the configurations of how it's built. So in order to understand the configuration, you need this generation config JSON file. This is sort of like the brains of how to put multiple shards together. So you can see here in the 70B model, each shard is like 5 gigs. So this one has 30 gigs of 5. So 5 times 3 is 150. So this is 150 gigs of data being stored here for this Llama 170B model. So 150 gigs is sort of so does the data set that it was trained on. So that means that in order for it to consume and build all these things, it needs to sort of create its own memory. So it needs to create its own parameters. So in these parameters, these could have special rules inside of it. So in one parameter could be this how it understands one part of the training data set, let's say physics. And then one other part of the data set could be the mathematics, could be other part of the training set. It understands that people live in houses, like just small context and rules. And the more data sets that you have, the more parameters it builds out and more rules it learns from itself. So when you see something that's 8 billion, that means it was trained on a smaller data set, but doesn't mean that because you have a smaller data set that your model could be worse, because you can have a smaller data set but super good. Like it can teach you all the rules an LM would need. It could teach you, like, it has everything in math sort of compact and be better. So for example, if you go on Hugging Face and you go to the leadership board, there might be some models that are smaller than someone that are bigger and have higher scores. You're like, wait, how does that happen? It's because their training data set is better. The training data set is more clean. It's not filled with noise. It actually gives the model more rules to sort of build itself out. So when you have larger models and you have all this training data set, that's why this is how, well, obviously the more data you have, the more clean data you have, the better, the smarter the model is. Now, going back to, let's say today's topic, let's say go back to Stargate, that Trump was trying to do when he first became president. OpenAI was trying to convince them, saying that if you give me more graphics cards, if you give me more space in Oracle, I'll be able to get you an LLM that's super smart, because with the more space, more data, I can build more parameters, and I can, instead of having a 640 billion parameter model, I can have a 2000 billion parameter model or a 3000 billion parameter model, and it will know everything and be able to run in everything, and we'll have large GPUs. And that's when NVIDIA stock shot up even more, boom, 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 boom. And then out of nowhere, DeepSeek came out, and DeepSeek's like, well, we have this really smart model, and we're not using as much graphics cards to run it. And that's what really caused it to tank, was that this model that was using less parameters, or less training data, less parameters, and be able to sort of section itself to work. That's where it's like, oh, I guess we don't need all these graphics cards to run an LLM or to run this anymore. If an LLM can be able to decide to activate only certain layers when required, that will reduce the compute and go from there, right? So this is why, like, NVIDIA's tanks dropped when DeepSeek came out, because it was sort of defying what OpenAI has said. So this is why you see certain models for me, like 5.4 is being trained from Microsoft, and they're really small models, but they're trying to when they train these models to have super clean data sets that are super small, compact, but has tons of rules that the LLM can learn and build on itself. So this is why I'm a big fan of these smaller models, because some of these smaller models can be run on your phone. You don't even need a computer for this because some of them are only 1 or 2 gigs of size, and they're really great. But again, they're not a smart, like I would say, smart intensive of what are you trying to do, right? If you're trying to do like a model that does reasoning, then you need something more than just 8 gigs, or you need something that's able to reason and redo multiple actions. You'll definitely need a lot more graphic cards from that way. But in summary, I know I just went to tangent that way, but there's a lot of things that from that
So
side.
in this particular example that you're showing, the entire storage needs for this model is this particular files, model 001, 002, and all that. That's it.
Yeah, so for this to run, you need to download all this to your computer. This 150 gig the shard here. You would then have to then load them. Once you load this 150 gigs, you have to load this on a type of memory, either GPU or CPU, right? So once you load that, the 150 gigs becomes 150 memory plus the unloading. So you probably another 200 gigs on top of that. So then you would need, again, this is where the costing comes in terms of local, is that you need to have either you run this on your CPU, and you need to have a really fast CPU for this to go, like have enough RAM on your computer if you're using CPU. But if you're using GPU, you need to have GPUs that have 100 gigs of VRAM memory built in, that can handle probably 3 or 4 in order to handle it to running at fast speeds. If you quantize this model, you could probably quantize it to be running on 30 gigs, but again, you lose then, like we are talking about before, performance. It could be running faster, but it could be things that it's now missing because you're now removing some layers or some rules that it learned, that may not act as the full model would be.
Yes. So this one should entirely fit in memory, not just on disk.
Correct. When you're looking at this, there's 2 ways to run it, either through your RAM or your GPU.
I see.
Yeah.
I
So this
see.
is why people have issues running these models locally, because you need to have a
So,
good.
I mean, it is trained. I mean, this particular model, I'm pretty sure it's trained on the entire internet, right?
Yeah,
Llama 70 or
Facebook.
so. I mean, that's a huge data, but it's kind of distilled and all. And finally, we have a smaller size, right?
Correct.
The original files are all thrown away, right? All the, I mean,
Correct.
exabytes of data, right?
Correct.
I see. So only the tensors are stored here.
So when you look at these files and you're looking at what's built in here, you'll see that you break down these are called shards.
Yeah.
Each shard it's not the original files, but it's the rules of what it means. So you're not seeing a conversation. Like, you won't see a conversation being stored there, like someone talking on Facebook. But you can see in the shard, like if you broke this into a neural network, you would see the connection of words, of the rules that you would see what each shard would have.
And also the embeddings also.
Correct. The embeddings of them as well.
Okay. And is it like a human readable form?
Um, you would have to understand the architecture of each LLM model. So, example, Llama has its own architecture, and ChatGPT has its own architecture. So the only ones be able to sort of break down and understand are open source ones, because what happens is ChatGPT doesn't give you the generation config file or your tokenizer configurations. Neither does Anthropic, neither does these ones. So these were considered not open source. So unless you have like the generation config files, unless you have how to map everything together, they're considered private. So this is what happens with ChatGPT on them. They don't release the architecture of it. But for open source ones, yes, you can sort of break down, look at each shard through the generation config, tell you exactly what's happening in each layer, what each layer does. And that sort of goes into a deeper class of understanding like the transformers. Why did had this? Why does this layer have certain rules? What did it learn during the learning process? What happened in the BERT model that it got captured in the GPT model? Yeah, it goes deeper into that.
Okay, thank you.
Yeah, great question. That's a lot of this is deeper than Janai 101, so this is awesome.
But I think sometimes this, perplexity and all, along with an answer, they give references. I think they have to store the references somewhere else.
Yeah, so the thing is every LLM is frozen. There isn't an LLM that's active. So what I mean frozen is that if you try to ask an LLM a question currently, like if you were to download this model and disconnect the internet from it completely, and you have no tools and you have nothing connecting to your LLM and you just have in a box, and you say, what year is this? It will say year 2024. This is the last date I was trained on. Because LLMs only have memory stored from when they're trained on. So this is what we call frozen LLMs. Only when you start integrating tools and agentic properties to these LLMs and saying, here's your LLM, but guess what? You have access to the internet. You have access to um, these tools. You have access to these Python functions. Use them if the user asks these questions. So this is where it becomes agentic, and this is what Perplexity does. It has Python functions built around the LLM for it to say, okay, when someone asks a question, break it out 4 or 5 different times, and then use the LLM tool search to go on the internet and pull information using APIs, and then store it together. So it's not the LLM actually going doing it. Perplexity just created like a wrapper around these LLMs to sort of have a good interface and be able to pull information and collate it together. So that's how Perplexity works currently. And this is why you can use multiple different LLMs in their system. You don't have to be tied to one. If you go to Perplexity and you can choose, okay, I want to use Claude, I want to use DeepSeek, I want to use this. It's because it doesn't matter. It's not based off the LLM. Everything's based off the wrapper. And just the LLM is just the smart things of just executing on it.
Yeah, so they have to store all these references outside the model.
Correct. So usually through APIs. When I do agentic tool calling with my LLMs, I use an API myself called Tavily, and then I tell the model to either use the Tavily API to extract information it doesn't have, or to search the internet for information. And then what it does is it's just like a RAG. Is that if you're asking what happens here, I'll send the API out, grab the information, and give it. The LLM itself won't store that information. It's just grabbing like a RAG, grabbing information and answering what it was able to pull from.
Okay. Okay, thank you.
Yeah. See if I can pull up Perplexity. I don't know if I
So
think I
I
still
I have a question. So OpenAI has released like a operator model like in the beta, or like I mean it's still in the like I mean like so just like OpenAI operator model, like are there any web UI or computer use models like I mean which can be used for like a web UI access and like a the way human interacts with the web?
Yes, and there's one that's out right now. It's sort of beta version. OpenAI is trying to create their own version as well. And I'll tell you exactly what that is. But just quickly, just showing on the Perplexity site is the wrapper is here, and you're able to choose whatever model you want, and then it will ask that question. So just quickly showing just how that wrapper looks. Now, going back to the question, there's something called MCP, which is called Model Context Protocol. So right now, Anthropic has the only one that sort of has open sourced this in terms of you can go in and try it. And what you do is you can install it on your computer, and it actually works through takes pictures of your desktop, works through your terminal, and it can actually aim and make responses. It can, for example, if you go and you download this MCP protocol, you can let Claude read and write files to your computer file system, be able to open browsers. You can have it do work. So this is called MCP Model Context Protocol. This is sort of a way to connect AI models to different data tools and sources. So you can learn how to build servers with it. You can have it go and open up your browser and search for stocks in the morning. And you'll see it actually move your mouse up to the top, click on it, write things, anything from there. So that's sort of what it's really official going on in terms of the type of information this way. What I've seen too, I don't advise this though, but like I've seen what people do is that they have multiple phone emulators on their computer. They download Anthropic's MCP and they tell the LLM to use each phone simultaneously to get more interactions for like a social media account, right? And I've seen people use like these things to like have these AIs be able to use and do more things on their computer than you typically have. But I would definitely say go in, get deeper into YouTube. There are MCPs there. The only thing you need to watch out for is that MCP uses APIs from Claude. Claude is not cheap. Claude will run up cost. So I would just say try to throw $20 into your to the testing beta of the API, run it, and then try to use it until you see how fast you can use that $20 pretty fast in your API usage. And then if that's something that's feasible, that's something you like to do, then go on from there, right? So that's definitely the number one thing that's sort of going on to use your computer, run your terminals and click your browsers and things like that. That's Anthropic has done this MCP from that. And then the second one was OpenAI is trying to do their own version with their alt agent desktop. I think this is the one. OpenAI adopts connecting AI models to data. Trying to think where it is. Yeah, so OpenAI loves stealing things. People love MCP and we're excited to add support across our products and our agent SDK. So yeah, this one here talks about more MCP. MCP lets models draw data from sources like business tools and software to complete tasks, as well from content repositories. So yeah, so if you even had an Excel file of all the people you need to email, each one needs to be a separate message individually. You can tell the MCP to prompt it to give separate messages, go to your Outlook and send emails out that way. So MCP is really powerful in the sense that it's that way. But again, remember, it's still in its infancy and there will still have some hiccups when you do something like that. But yeah, OpenAI has something in their agents SDK version to have their own. They're trying to try their own because it's huge and it's the next thing coming out. But right now, I would say the best one is trying to use Claude's MCP version.
And there is one repository in the GitHub browser use. Like, I mean, there are some reviews in the YouTube. Like, I mean, how safe is to use that one?
Which one?
Browser use. Let me ping that.
Yeah, maybe put that in the chat.
Yeah, sure.
There's so many tools out there today. Just
Like, I mean, this is to order like an online, like any browser, login into the any browser and add to the cart and order. I mean, choosing Anthropic or OpenAI or anything.
yeah, this is like a version, but this one only connects to your browser, right?
Yes, yeah.
Okay, look up models of license. Interesting, yeah. So it's like MCP for sure. But this one, yeah. So the difference between this one MCP and this browser is that it's not only tied to your browser. You can tie it to any of your softwares. So let's say you have a Salesforce platform and you need to look at the top leads. You can tell the MCP to look at your top leads that you have. Go into your browser, write separate emails, exactly what this is doing, and put the information from there. So it doesn't have to, it doesn't have to rely strictly on just using the browser. It can use multiple different apps. And that's all, I think that's the advantage of using MCP versus just this. But yeah, this looks good if you want to install something. But yeah, I think you need to use Chromium, right? The Chrome browser for that. Yeah.
I mean, does the MCP just you look at the UI and make the decisions, or it's more than that?
No, so like an example would be, I'm not sure if you guys played in your AI Google Studio. It actually uses the MCP, what uses the multimodal model from Claude to do it. So an example would be, let's see here. I'm not sure if you guys played around with this, but if you go stream real time, and then let me share my screen one more time because I think I have to include audio. Hold on. Share sound, share. And then I can say, show Gemini, share your screen. And I'm going to share it, our Zoom meeting. So what's going to do in this thing is how do you see how it's sort of take a screenshot? Hey, Google,
You want to know how to... Hi, how can I help you?
can you tell me who's in my Zoom meeting right now?
Sure. Based on what I see, the people in your Zoom meeting are Luis, Manoj, Santosh, iPhone, Swaroop Danthu, and Sridhar. Would you like me to tell you anything else?
What else do you see on my screen?
Okay, besides the meeting participants, I see a chat window on the right side of the screen. It contains several messages, including links and the phrase quantization. There's also a title at the top that says General AI 2025 to 102 Office Hours. Is there anything specific you want me to look at on the screen?
I'll stop it there. So what this is doing is, as you can see, I didn't prompt it, I didn't say anything. It was able to view what's on my screen, let me know exactly what's happening. It was able to identify everyone who was on the Zoom chat that was on the first 5 windows for me, and then do that. So how I was able to do that is through multimodal imaging. What it does is take screenshots of my page, as you can see here, and then be able to read it in real time and respond with voice to text. So it really, so MCP, the difference with adding MCP is then I can say, okay, can you minimize this browser and open up my Safari at the bottom of the window? So instead of just talking about it, MCP will then move my mouse to exactly where I have on the window screen, where it knows where it saw the minimize button because it took a screenshot of my screen, and then be able to close it and open it from there.
Okay, so this is not using MCP, but it is using something like screen scraping or something.
Yeah, so the multimodal model then uses screenshots. It screenshots your screen, gives it to the model, and then the model is able to then use an image decoder, extract the text, and then be able to respond in real time.
Okay.
And it's really great. So you can try different ones as well. You can go in here and do a video analyzer. You can turn on your webcam. You can wave to it, ask how many fingers you're holding, bring more people on the screen, ask them what they've seen, and go from there. So it's really cool that way. So there's lots of capabilities with LLMs out there. And this course is only specifically on text. Unfortunately, if I go to the multimodal parts, that requires a lot more learning, but for sure. Okay, guys, we just ran out of time. Thank you for joining for me every day. Hopefully this was informative for everyone. Everyone's able to see a little bit more of how to use LLMs daily, what are the next capabilities. And this Saturday, we're going to be continuing on how to lead the change, and as you can saw today, how powerful LLMs are, and be able to how to determine the cost of using this. So that's sort of what be this Saturday's class coming up. Okay. All right. Thank you, everyone.
Thank you, Luis.
Thanks, Luis.
You, Luis.
Thank you.
Thank you.